All right, now this is still, we're working on Unit 3. This is day 2, so we are on page number 5 of your packet. We're going to start working through, yesterday and today we identified vertical and horizontal asymptotes, so just starting to work with them, and now we're going to start, excuse me, putting them into graphs. All right, so to start off, so page number 5, number 1, find any horizontal and vertical asymptotes for that function. All right, for the vertical asymptote, we work with the bottom. We want to know where the problem spot is for the x values. So we solve for x, and we get x equals -2. Okay, that exact equation there, x equals -2, is the vertical asymptote equation. You do need x equals, don't just write -2. Because that's not going to actually give you equation. You need the equal sign, you need the x value for that. How do we get the vertical asymptote? Set denominator equal to 0 and solve. All right, so then we go on to the horizontal asymptote. So the horizontal asymptotes, as a reminder, we need the degree of the top and the degree of the bottom. So the degree of the top, when you compare the degree versus the degree of the numerator versus the degree of the denominator. So the degree of the top, there is no x's there, so that is a 0 for the numerator. For the denominator, x plus 2, the degree is 1, so I'm comparing a 0 to a 1, so I know it's less than. Alright, so when the top is less than the bottom, it's an automatic asymptote at y equals 0. So why is this the horizontal asymptote? Because the degree of numerator is less than the degree of denominator. So it's automatically y equals 0. Alright, so there's a little warm up there. Number 2, do the same thing. If this is a good place to pause it so you can try to do it on your own and then check, that's fine. Otherwise, here we go. For the vertical asymptote, I set the denominator equal to 0. I don't have any solving to do, so I automatically have x equals 0. That is the line, the vertical line through 0 on the x-axis. For the horizontal asymptotes, I need to go the degree of the top. The degree of the top is a 1, the degree of the bottom is a 1, so I have 1 equals to 1. So this is where I need the leading coefficient of 4, and I make it into a fraction with the numerator and the denominator. So I have the leading coefficient on the numerator is 4, the leading coefficient on the denominator is 1. So I make the equation y equals 4 over 1, or y equals 4. And why is that the horizontal asymptote? Because the degree of the top, numerator, equals the degree of the bottom, the denominator. So I do the leading coefficient of the top over or divided by the leading coefficient of the denominator, so the bottom. So that's 4, 1. Alright, so using those ideas, we're going to start making some graphs today. So we're going to do some basics. I'm asking you for vertical asymptotes. I'm asking you for horizontal asymptotes, x-intercepts, and y-intercepts. Alright, so go ahead and get the vertical and the horizontal asymptote. X minus 2 is equal to 0, so x equals 2. The vertical asymptote is at x equals 2. The horizontal asymptote, I have the degree of the top, which there is no degree, so it's a 0, versus the 1 on the bottom. So just like that first one we did, the degree of the numerator at 0 is less than the degree of the denominator, which is 1. So automatically it's y equals 0. So those two lines, the vertical asymptote through 2. So we looked at those yesterday when we did some graphs and just pointed those off. So you're just making the vertical line dashed or dotted, doesn't matter, through 2 on the x-axis. The horizontal asymptote needs to go through 0 on the y-axis. So on that one, you are actually going through the origin and covering the x-axis. Now, to do the x-intercepts, this is when y equals 0, and actually you set the top of the fraction equal to 0, or you just take it and say 0 for the y value, so the function is equal to 3 over x minus 2. We go into some cross multiplying and multiply diagonally. So I have 1 times 3 equals 0 times blob, so 0. Wait, what? That doesn't work, right? So this doesn't work, so this means there's actually no x values or x-intercepts, so there's none. Don't leave it blank, none. Put a scratch through it, no solution, something to indicate that you've already identified, you tried it, and there's nothing. Alright, for the y-intercepts, the y-intercept is when x equals 0. Plug that into the equation. So you have 3 over 0 minus 2. So you got 3 over negative 2. So you got y-intercept at negative 3/2 or negative 1.5. Alright, so the next thing, this says without a calculator. So this, I'll check, but this may mean without a graphing calculator because I don't need you copying it from that. What you need to do, okay, if I had x-intercepts, I would put them on the x-axis, but I don't have any, so no dots on the x-axis. The y-intercept is at negative 1.5, so on the y-axis I go down to negative 1.5. Now you want to kind of get an idea of where the graph is. Is it side to side? Is it diagonally? Is it up and down? So you need to plug in some of these other numbers into the actual function. So I just need to make like a quick graph and make a couple table values. So I would say you need like 3 for each part of the graph. So there will be 2 pieces because I have an asymptote here. I'm going to have 2 parts to this. There's not going to be 3 values. I'm not going to have them in 3 quadrants here. So what you need to do, plug in some of these values. So if you have a horizontal and vertical asymptote, this is kind of cutting it off for you, saying, all right, I need to figure out what's happening here at 1. So with a point down here at negative 1.5, hopefully it's down there, but make a quick table. If I plugged 1 into this, I'd have 3 over 1 minus 2, so negative 1, so I get negative 3. So 1 and negative 3. I also want to try to avoid as many decimals as I can, so I'm not going to get closer to that. I'm actually going to go the other way here. So I'm going to go to 0, I'm going to plug in a negative 1. Okay, so I have 3 over negative 1 minus 2, negative 3, so this makes negative 1. Okay, so you can see some 3 points on your graph here. So the graph is going to curve like this. Now I need to also figure out what's happening on the other side of the asymptote. So I already figured out what's happening on the left side. Now I need to figure out the right side. So I need to plug in some numbers over here going to the right. So I figured out, I know 1 is down here, 2 is here at the asymptote. So I need to know what's going on at like a 3, 4, and 5 or something like that. So at 3, I plug that in. I have 3 over 3 minus 2 is 1, so I get 3. Same idea, I plug 4 in. I have 3 over 4 minus 2, so 2, so 1.5. If I plug 5 in, I'd have 3 over 3, which makes that a 1. So I have 3 points for that side now. So I have 3, comma 3. 1, 2, 3. I have 4 and 1.5. I have 5 and 1. Okay, so there's your graph for it. All right, so this next one, go ahead, get the horizontal asymptote, vertical asymptote. Compare the degree of the top. So leading coefficient over leading coefficient. So y is equal to 2. X-intercepts is when I plug in a 0 for the y. This actually means I set the top equal to 0. So I have 2x that's equal to 1, x equals 1/2. So it's 1/2, comma 0. The y-intercept are when all the x's change to a 0. So I have 0 minus 1 over 0. Oh, I can't do that, right? So I have negative 1 over 0. It's undefined. It can't happen, and that's why we have a vertical asymptote going through 0, so that actually matches up. So there's none of that. All right, so I have 2 asymptotes to put on. X equals 0. So 0 on the x-axis is here. It's vertical, so it goes up and down. So it goes up and going down through there. Y is equal to 2. That's here. 2 on the y-axis. I have x-intercept is 1/2 and 0, and there's no y-intercepts. All right, so kind of thinking about some stuff. If there's only one x-intercept here, and it's already on the graph, I can't be down here below on this x-axis. I can't be below this asymptote on the left because I have no more x-intercepts here. So this is actually going to go diagonally for us. All right, so I need some numbers to plug in. So I need like a 1, a 2, 1 and a 2 on that side. And then on the other side, I need like negative 1, negative 2, negative 3. I want 3 points on each side. All right, so you plug in 1 into the equation. 2 times 1, 2, minus 1, 1, over 1. By 1, 1. The next one, I plug in a 2. 2 times 2 is 4. Minus 1 is 3 on top. Over 2 on bottom is 1.5. So you can see it going up, getting close to that one, and going towards that. Okay, on the other side, for the negative 1, I have 2 times negative 1, negative 2. Minus 1 is negative 3. Over negative 1, which makes it positive 3. And see, now you are above that for horizontal asymptote already, so we're not going to be going through the x-axis here at all. Next number, plug in negative 2 and negative 3. So negative 2, 2 times negative 2, negative 4. Minus 1 is negative 5. Over negative 2. Whoosh. I'm running into my own problem. My own stuff here. Negative, or positive 2.5. So 2 and 2.5. And last number here, negative 3. So I plug negative 3 in. 2 times negative 3 is negative 6. Minus 1 is negative 7. Over negative 3. They changed to positive. It would be 2.3 repeating. 2 and 1/3. So 2 and 1/3. All right, so that's where we're going to stop for today. No more notes on that. We're going to do some work on the other stuff in class tomorrow. Let me know if you have questions. Thanks. Bye.